In section 6.4, we're going to talk about permutations and combinations. So first we're going to talk about the fundamental counting principle. If event M occurs in M ways and event N occurs in N ways, then event M followed by event N can occur in M times N ways. So basically all our different options, we can just multiply together and that gives us all our different possible combinations. So easy example here, let's say I'm at a restaurant and there are 4 entree options and 6 drink options. To figure out every single possible meal combination I could have, I would do 4 for the entrees because I could pick 1 from that, times 6 for my 6 drinks options. There are 24 possibilities. So now let's move on to an example here. So let's say I'm online and I'm ordering a burrito bowl from Chipotle. So here I have all my options. How many different possibilities for a burrito bowl are there if I get 1 protein and 1 topping? So I start by looking at all my protein options. There's 6 times I can get white or brown rice. So that's 2 options. Times if I want to get beans, that's 2 options again. Times there's 11 toppings. So to get all my different possibilities, again, if I just get 1 topping and 1 protein, I would do 6 times 2 times 2 times 11. And there are 264 possibilities for different types of burrito bowls. So again, knowing that we could multiply these is way more efficient than actually writing all these out and writing over 200 different possibilities. So from here, along with counting, there's 2 important definitions we have to go over. And that's a permutation versus a combination. A permutation is an arrangement of items in which the order of the object is important. So you want to think about this. For a permutation, order matters. On the other hand, a combination is a selection of items in which the order isn't important. So for a combination, order doesn't matter. I would definitely highlight that and know that order matters for a permutation, doesn't matter for a combination, then we're ready to move on. So let's say I go back to my Chipotle example, and let's say I want to be less boring and I want to pick more than 1 topping. So let's say I want to get 5 toppings. And let's say I'm ordering, pretend that I'm in the line, I'm at Chipotle, and I say I want guacamole, cheese, fajita veggies, tomato salsa, and sour cream. Would I get a different burrito bowl if instead I said I want sour cream, tomato salsa, guacamole, cheese, and fajita veggies? No, it wouldn't. Order doesn't matter here. So I want to use, if I want to figure out how many different possibilities there are, a combination. So if I want to pick 5 toppings out of the 11, how I'm going to enter into my calculator, it'll be 11, choose 5, and there's a C for a combination. Now, there's an easy way to do this in your calculator, so we'll do that in class tomorrow. If I enter this correctly in my calculator, I end up getting 462 possibilities. So what that means is that out of 11 toppings, if I'm choosing 5, there are 462 ways that I could choose 5 toppings. Again, the order doesn't matter here, because the order in which I say those 5 things won't change the outcome. In our last example, students in National Honor Society are being chosen for cabinet positions. Let's say there are 30 members, and how many ways can I choose a president, vice president, and treasurer? In this case, the order matters, because if I pick Joe to be president and Mary to be vice president, that's different than if Mary's president and Joe is vice president. The actual position, since there's a name attached to each position, it's going to be a different outcome if I switch up the order in which I pick them. So I'm going to use a permutation. Again, this is an easy thing to do in your calculator. We're going to do 30 P3. So out of 30, I'm going to pick 3. And there are 24,360 different options that I could do here. And that's it.